Hi everyone, welcome back. Today we'll be doing section 3.4 on linear functions. Now most of this section should be a review from your Math95 days. We're just sort of putting a couple new spins on things that you've already done. So the general format for a linear function is f of x is ax plus b. A and b generally are in the set of real numbers if we're looking at a linear function. For chapter 3, a and b, we're going to want them to be in the set of integers. M is used as the notation for slope in any type of linear situation. And slope is just the ratio of the vertical change to the horizontal change. So a change in something is a subtraction problem. If the number of people in a room changes from 10 people to 4 people, it changed by 6 people. You're just doing a subtraction. So change is indicating a subtraction problem. So they start us looking at function f of x is, we'll go with negative 3x plus 5. So a little review on function notation. If we want to find, say, the y value when x is 1, we would find f of 1. So that would be negative 3 by 1 plus 5. So f of 1 is negative 3 plus 5. So f of 1 is a positive 2. So this is equivalent to saying we have the ordered pair 1, 2 on function f. And we could pick out another point, let's say at 4. F of 4, negative 3 by 4 plus 5. So f of 4, negative by a positive is a negative. And adding and subtracting, unlike signs, subtract the absolute value, keep the sign of the number further from 0. So 4, negative 7 is also a point on our graph of f. So our slope, which again is represented with an m, change in the vertical divided by change in horizontal. Now you remember hopefully from your Math95 days, the y's are the vertical axes, x is typically your horizontal axis. So I like to just sort of set up my framework where I'm going to plug in any numbers. I'll put in parentheses. So y values of 2 and negative 7. Corresponding x values of 1 and 4. What I meant by corresponding, as soon as you pick who goes first for your y's at the top, you set in stone who goes first for your x at the bottom. So remember, minus a negative is really plus. So up top is really worth 2 plus 7. On the bottom, 1 minus 4. So m is equal to 9 divided by negative 3, which is negative 3. Now, if I had changed up the order of the points, as long as I was consistent with that, I would still get the same answer. So if I picked the negative 7 to go first at the top, that would mean that its partner 4 had to go first at the bottom. So up top I'd have a negative 9, down at the bottom a positive 3, which still gives us a slope of negative 3. Now you might notice that that number appeared in our original function. If we go back to our f of x is ax plus b and find ourselves a couple ordered pairs, we can prove that that will work all the time. So let's find f of 0 and f of 1. So f of 0, a times 0 plus b. By the zero product property, that is then 0 plus b. And finally, by the additive identity, f of 0 is b, so we have 0b. F of 1 be a times 1 plus b. By the multiplicative identity, a times 1 is the same as a. And unless I know something more about a and b, that's as far as we can go. So we have order pair 1, comma, the quantity a plus b for a y value. So if we go through finding the slope with this, change in the vertical divided by change in the horizontal. So I'll do a plus b minus b, and I'll do then 1 minus 0. At the top, a plus b minus b is a plus 0. At the bottom, 1 minus 0 is 1. Additive identity up top. And finish it off with multiplicative identity. So our slope is always a. So really we can shorten, not shorten, we can sort of change up and do a more informative version of the function notation for linears. F of x we can say are represented by mx plus b. So m is the slope. And one other sort of corollary, a freebie from doing the other proof we got, is that 0b is always going to be our y-intercept. So they also sometimes will ask us about an x-intercept for a problem. We'll do just a quick little side mini review problem as far as x-intercepts. So here's my x-axis, here's my f of x axis. This point right here is an x-intercept, and that's sitting at -1, 0. Right here we have another x-intercept that's happening at 2, 0. And in general, if I'm on the x-axis, my y-coordinate has to be a 0. So anytime they ask you for an x-intercept, automatically your brain tells you y must equal 0. Or if it's in function notation, we can say f of x equals 0. So if they ask for the x-intercept for y is -8x plus 24, as soon as I see x-intercept, automatically my thought bubble goes to there, y equals 0. So we substitute and solve. So same properties that we've been using all since chapter 2. So addition property of equality, additive inverse, additive identity on the other side. Then we'll multiply both sides by -1/8. That's the multiplication property of equality at work. So arithmetic on the left-hand side, negative by negative is a positive, an eighth of 24 is 3. And we'll mentally apply the associative property of multiplication, multiplicative inverse. Gets us to 1x, so x is 3. So our ordered pair then is 3, 0. That would be then our x-intercept. Anytime we see x-intercept, we know it's going to be something, comma, 0. Similarly, a y-intercept is always going to be 0, comma, something. for example, if they give us, let's say g of x is negative 4x plus 7, if they ask us to find the slope, automatically we know m is negative 4. Notice I'm not bringing that x along as part of the slope. The slope is just a number, not a number times a variable. If they ask us for the y-intercept, as long as they're in this nice, neat, pretty function notation, we can just at a glance tell that that must be 0, 7. So there's my m, there's my b. M equals negative 4, y-intercept 0, 7. Now, occasionally they do ask us to write the equation of a line. When we want to do that, it's useful to think back to our work with the slope formula. So slope, remember, was a change in y over a change in x. Delta represents the words change in. Well, if I want to solve this thing for, let's say, change in y, think back to your rational equation days, we would simply clear the fraction using the LCD. So I'll multiply both sides by change in x. So change in x divided by change in x is 1. 1 times change in y is change in y. So change in y is your slope times your change in x. And that's really all we need to be able to write our slope formulas. Remember, change is a subtraction problem. So we'll find a function describing the line with slope of negative 6 containing negative 3, positive 4. So we'll go with the new version of the slope formula, change in y. So y minus something is our slope times change in x, x minus something. Then we fill in what we know. The y value we have is a positive 4. The slope they gave us, m, is negative 6. And our x value was a negative 3. Here's why you're using those parentheses. This is from the fact that we have a subtraction problem. This is from the fact that I happen to be working with a negative number. It's very easy to get those mixed up if you're not using the parentheses. So then we want to simplify where we can. So left side, I don't necessarily need those parentheses after the first step. Right side, though, there is a little bit of cleanup to do. So negative 6 by x plus 3. Then we'll go ahead and apply the distributive property on the right side, which means we just bring the left side along. We're looking to go to function notation, which means we want a y by itself so that the y can get replaced with a f of x, g of x, h of x, whatever name we give it. So y plus 0 turns into a y, negative 6 minus 14 on the right-hand side. And then, again, they wanted us to write it as a function, so we give it a name. F, G, H, whatever letter we pick other than x, y, m, or b is negative 6x minus 14. So our next one, similar start, only instead of handing us the slope, they're going to make us do the work to figure out a slope. So this time our line will contain negative 2, negative 16, and negative 5, negative 37. So the only difference between this problem and the last problem, let's say they still want function notation. Talk about other notations soon. Only difference between these two problems is last time they handed me the slope, this time they're making me find it. So that's the first order of business then. Set up my slope formula, one subtraction problem over another subtraction problem. Then I go back through and just fill in what I know. So my y value is negative 16 and negative 37. My x value is negative 2 and negative 5. So up top turns into negative 16 plus 37 minus a negative 37, changes it to a plus. Downstairs, negative 2 plus 5. So our slope for this one, so unlike signs, so we'll subtract those absolute values. And the positive is further from 0. It'll stay positive. Do the same thing at the bottom. So we have a slope of 7. So now basically I have a point and a slope, or I have this point and a slope. You'll get exactly the same function either way. So if one ordered pair looks easier than the other, use the easier ordered pair. This one, neither one of them would be too terribly difficult, but slightly smaller numbers on my first point. So I'll take those two bits of information and I'll go ahead and then pick it up basically from where the last problem left off. So we're going to have a point of negative 2, negative 16. And a slope of 7. So our change in y is worth our slope times our change in x. So y minus a negative 16 is our slope times our change in x, x minus negative 2. So we'll do any simplifying first. Left side y plus 16, right side 7 by x plus 2. A little bit of distributive property next. And then we just get the y by itself. So I'll subtract 16 on both sides of the equation. Y plus 0 turns into a y, 7x minus 2 on the right-hand side. And then we just give it a name. So there is our function. So let me have you all try one out. So same instructions as last time, just new points. Negative 1, positive 23, and 5, negative 13. So see if you can write a function describing the line that connects those 2 points. Go ahead and pause the video and we'll pick it up and finish it together. Okay, welcome back. So first thing I need if I'm writing the equation of a line is a slope. So change in the vertical over change in the horizontal. So 23 and negative 13. If I pick 23 to go first at the top, negative 1 goes first at the bottom. If you had picked the negative 13 first at the top, then 5 went first at the bottom. So up top, 23 plus 13. Downstairs, negative 1 minus 5. So our slope m looks like we have 36 divided by negative 6. If you went the other way, you got negative 36 divided by positive 6. Either way, we have a slope of m equals negative 6. You do need the m equals. So then we just go to our change in y is the slope times change in x. So y minus something is our slope times x minus something. And we'll get the same answer either way. I'm going to show both. Just follow along with whichever of the 2 ordered pairs you used. Don't worry about the other one. Okay, so some of you use the first point, so 23 for your y value. Slope for everyone was -6, and your x value would have been a -1. Our other group, if you tried it the other way, -13 for the y value, -6 was still your slope, and 5 was your x value. Again, don't write them both down, just whichever one you did. So y minus 23 is -6 by x plus 1, or y plus 13 is -6 by x minus 5. In both cases, next thing is distributive property on the -6. So y minus 23 is -6x minus 6, or y plus 13 is -6x plus 30. Next order of business, we are done simplifying, so we want to then get the y by itself. So depending on which one you did, you're either adding 23 to both sides or subtracting 13 on both sides. So we have y plus 0 is just y, so y is -6x. Unlike signs, so we'll subtract those absolute values. The positive was further from 0. So -6x plus 17. And notice we get the same thing on our other one. Y is -6x plus 17. And then we just gave it a name. F of x, g of x, h of x, k of x. Anything other than basically m, x, or y. I also wouldn't use b since 0b is typically expressed for the intercept. So g of x, -6x plus 17. So there is one other form other than the slope-intercept form, which you learned in 95, and the function notation, which we've been going over, and that is the standard form. In the standard form, basically you want all of your variables onto one side. So just ax plus by equals c. So here a, b, and c are in the set of integers, since we're still in the sort of chapter 2-3 mindset of working with integers. Okay, so they're going to ask us again to write the equation of the line, this time in standard form. And this time they tell us that it contains points 1, -2, and -5, +22. And again, their goal this time is standard form. Doesn't start any different no matter what form they ask me for. I have to know what the slope is, and if they don't hand it to me, I have to do the calculations to find it. So let's see, my y value is a -2 and a 22. My x value is a 1 and a -5. So up top, -2 minus 22. At the bottom, 1 plus 5. So slope m, -24 over +6. Negative over positive is a negative. 24, 6 is 4. So we have a slope of -4. Use either ordered pair. Most of you would probably pick the 1, -2, since we do have smaller values on that. So again, we start with change in y is the slope times change in x. Change in is always a subtraction problem. So change in y minus a -2 is the slope. We figured out m was -4. Change in x, our x value that went with the -2 was a +1. Just like before, we simplify where we can, so y plus 2 is -4 times the quantity x minus 1. We distribute just like before. Y plus 2 is -4x plus 4. We can subtract 2 on both sides as usual. plus 0 is a y is negative 4x plus 2. The only difference is, instead of naming this function, if we want standard form, instead I'm going to move that x out of the way. So I will add 4x to both sides. And since addition is commutative, typically the x is written as the first term, y is written as the second term in standard form. So we have 4x plus y. That's where 0 plus 2 will simplify down to a 2. So that would be our equation in standard form. Okay, let me have you all try one out. So same instructions, you're going for a goal of standard form. And your points now to -9 and -1, +9. Okay, so go ahead and pause the video, and when you're done, unpause it, and we'll finish it together. Okay, welcome back. So hopefully you remember, first thing is we find the slope, which we label as m. Yes, you do need the label. So one subtraction problem over another. So our y values, -9 and 9. Our x values would be a 2 and a -1. If you put the +9 first, that's okay, as long as you also put the -1 first. You'll get the same slope that we get. So -9 minus 9 upstairs, 2 plus 1 downstairs. So -18 divided by +3. So our slope m is a -6. So after that, we just go with change in y is slope times change in x, which is really just the slope formula shuffled around. We just cleared the fraction out of the slope formula. So y minus something is our slope times x minus something. Remember, change in is always subtraction. Again, I'll go ahead and show both. You do not need to write both, just write down whichever one you tried. All right, so if you use the first order pair, your y value was -9. Anyone, your slope was -6, and your x value was 2. If you use the second order pair, your y value was a +9, slope was still a -6, and your x value was a -1. And then we want to simplify where we can. So y plus 9 is -6 by the quantity x minus 2. If you want the other way, y minus 9 is -6 by the quantity x plus 1. Again, remember, you don't have to write both of these down, just the one that you did. So whichever route you took, the next step is distributing the -6. So I hang on to the left side and distribute the -6. Next, we want to move our constant out of the way, either a 9 or -9, depending on which ordered pair you used. So if you use the first ordered pair, you're subtracting 9 on both sides. If you use the second ordered pair, you're adding 9 on both sides. So y plus 0 turns into a y. So notice we get the same equation out of it. So from there, we finish it off by adding 6x to both sides. And go ahead and use the commutative property of addition. So there is your standard form for the equation of that line. So that should give you enough information to try out the homework from section 3.4. So remember, those are found at the end of the chapter. Any questions, please feel free to email me. Otherwise, I will see you next time.